Hello everyone. This is our first lecture for Chapter 9, An Introduction to Hypothesis Testing. Here are the learning objectives for Chapter 9. This is what we are going to cover, and this is what you will need to know for the next proctored quiz. Think of these learning objectives as your roadmap through the chapter and your study guide for the next quiz. So take a minute, hit the pause button, and read through these. In this lecture video, we will continue to explore inferential statistics. We will continue on our journey into inferential statistics with hypothesis testing. Specifically, we will define hypotheses, hypothesis testing, and discuss the 4 steps to hypothesis testing. We will talk about the 2 types of hypotheses. We will discuss non-directional or 2-tailed versus directional or 1-tailed hypothesis tests. Before diving into the logic of inferential statistics and hypothesis testing, I want to use a non-statistical example of hypothesis testing. A criminal trial is an example of hypothesis testing without the statistics. In a trial, a jury must decide between 2 hypotheses. The null hypothesis is the defendant is innocent. The alternative hypothesis or research hypothesis is the defendant is guilty. The jury does not know which hypothesis is true. They must make a decision based on the evidence presented by the prosecution. The trial always begins with the assumption that the defendant is innocent or that the null hypothesis is true. The goal is to determine whether or not there is enough evidence that the defendant is guilty, or there's enough evidence to support the alternative hypothesis. In the language of statistics, convicting the defendant is calling rejecting the null hypothesis. The jury is saying that there is enough evidence to conclude that the defendant is guilty, or there is enough evidence to support the alternative hypothesis. If the jury acquits, it is saying that there is not enough evidence to support the alternative hypothesis. Notice that the jury is not saying that the defendant is innocent, only that there is not enough evidence to support the alternative hypothesis. This is why we never say that we accept the null hypothesis. There are 2 possible errors. One error is if the jury declares a defendant guilty when the defendant is in fact innocent. The second error is if the jury declares a defendant not guilty when the defendant is in fact guilty. In our judicial system, we try to avoid convicting innocent people, and we are more willing to acquit guilty people. If you have ever been on a jury, the judge instructs you to find the defendant guilty only if there is evidence beyond a reasonable doubt. We will discuss these errors in detail later on. So now let's get into the specifics of inferential statistics. Remember from our last chapter that there are 2 types of inferential statistics. Estimation, which we covered in Chapter 8, we learned about point estimates and confidence intervals. And the second type is hypothesis testing. Remember, we use inferential statistics because it allows us to observe samples to learn more about the behavior in populations that are often too large or inaccessible to observe. We use samples because we know how they are related to populations. In Chapter 6, we learned that the sample mean is an unbiased estimate of the population mean. If we select a random sample from a population, then on average, the value of the sample mean will equal the value of the population mean. In research, we select samples to learn more about our populations of interest. We calculate a sample mean to learn more about the mean in a population. So, we will use sample means to describe population means. We start by stating a hypothesis about the value of a population mean, and then we select a sample and calculate the mean in that sample. On average, the value of the sample mean will equal that of the population mean. The larger the difference or discrepancy between the sample mean and population mean, the less likely it will be that the value of the population mean we hypothesized about is correct. Before moving on, let's quickly define hypothesis. It is a statement or proposed explanation or prediction for an observation, a phenomenon, or a scientific problem. A hypothesis is always a statement about a population parameter. The way we evaluate samples to learn more about the characteristics in a population is called hypothesis testing. Hypothesis testing is just a systematic way to test claims or ideas about a population. It is a statistical procedure for testing a claim or prediction about a population parameter. So for example, let's say we read an article stating that children in the United States watch an average of 3 hours of TV a week. To test whether this claim is true for preschool children, we record the time in hours that 100 American preschool children, the sample, among all children in the U.S., the population, watch TV. The mean we calculate for these 100 children is the sample mean. We can then compare the sample mean from our sample to the population mean stated in the article. The goal of hypothesis testing is to determine the likelihood or probability that a sample statistic would be selected if the hypothesis about a population parameter were true. There are 4 steps to hypothesis testing. Step 1, state the hypothesis. We identify a hypothesis or claim that we feel should be tested. For example, we might want to test if the mean number of hours that preschool children in the U.S. watch TV is 3 hours per week. Step 2, set the criteria for a decision. The criteria is the significance level or level of significance, which is a probability. In hypothesis testing, we collect sample data to show whether the null hypothesis is true or not. For example, using the hypothesis of whether preschool children watch 3 hours of TV per week, if preschool children watch 3 hours of TV per week, then the sample we select should have a sample mean close to or equal to 3 hours. If preschool children watch more or less than 3 hours of TV per week, then the sample we select should have a sample mean far from 3 hours. However, at what point do we decide that the difference between sample mean and population mean of 3 hours is so big that we can reject that preschool children watch 3 hours of TV per week? That point is our criteria or level of significance. Step 3, calculate the test statistic. We select a random sample from the population and calculate the sample mean. For example, we could select 100 preschool children and calculate the mean time in hours that they watch TV per week. The test statistic that we have learned so far is the z-statistic. So we would calculate the z-score and find the probability for the sample mean we calculated. Step 4, make a decision. Determine if the sample mean we calculated is close enough to the population mean, that would be a large probability, or the sample mean is far enough away from the population mean. That would be a small probability. So let's go back to step 1, state hypotheses. Hypothesis testing is based on 2 types of hypotheses, the null and the alternative hypotheses. The null hypothesis is a statement of status quo in the population, a statement that there is no difference, no change, no effect, or no relationship. The null hypothesis always contains a statement of equality. It is a statement that the population parameter takes a particular value. The null hypothesis is always assumed to be true until evidence indicates otherwise. Back to our example for preschool children, the null hypothesis in words is preschool children in the U.S. watch an average of 3 hours of TV per week. This null hypothesis in symbols is as follows. H0 is mu equal to 3 hours. The alternative hypothesis is a statement that in the population there is a difference, a change, an effect, a relationship. It directly contradicts the null hypothesis by stating that the actual value of a population parameter is less than, greater than, or not equal to the value stated in the null hypothesis. Notice that the alternative hypothesis contains a statement of inequality. The alternative hypothesis is usually a statement we are trying to find evidence for or a claim that the researcher believes to be true. Back to our example for preschool children, the alternative hypothesis in words is preschool children in the U.S. do not watch an average of 3 hours of TV per week. The alternative hypothesis in symbols is H1 mu not equal to 3 hours. There are 3 ways to set up the null and alternative hypotheses based on directionality. In a two-tailed hypothesis test or non-directional hypothesis, the researcher does not predict the direction of an effect or difference more than or less than. Typically the question will be, is there an effect or is there a difference? This signifies a non-directional hypothesis. The null hypothesis will always be stated as HO mu equal to some value. And the alternative hypothesis will always be stated as H1 mu not equal to some value. In a one-tailed hypothesis test or directional hypothesis, the researcher specifically predicts the direction of an effect or difference, more than or less than, or an increase or decrease. There are 2 ways to set up directional hypotheses. So let's start with right-tailed hypothesis tests. Typically the question will be, is there more than, or is there an increase? The null hypothesis will always be stated as H0 mu less than or equal to some value. And the alternative hypothesis will always be stated as H1 mu greater than some value. Notice how both of these hypotheses include the full range of values that could occur. Also notice that the direction of the inequality sign in the alternative hypothesis points to the right for a right-tailed test. Now, for left-tailed hypothesis tests, typically the question will be, is there less than or is there a decrease? The null hypothesis will always be stated as H0 as mu greater than or equal to some value. And the alternative hypothesis will always be stated as H1 as mu less than some value. Notice again how both of these hypotheses include the full range of values that could occur, and also notice that the direction of the inequality sign in the alternative hypothesis points to the left for a left-tailed test. In our next video, we will discuss how to set a criteria or significance level. We will talk about effect size and decision errors.